Hello, welcome to this Spatial Spotlight session. My name is Giulia Carella and I'm a data scientist at Carto. Today we're going to talk about how to identify areas where to prioritize network development to improve the accessibility to senior citizens in the US. This is a very interesting use case, especially since the Access broadband network in 2021, which set a lot of investments to close the digital divide in the US and improve network accessibility to all citizens. So we're going to imagine today that we are a network operator, a telco operator in the US, and we want to create a priority score to decide where to invest in terms of network development to improve the accessibility to seniors in the US. So let me share my screen, and we're gonna start our use case. We're gonna imagine to have access to some telco data about the network speed of our clients, as those you can see here in this map, which shows the average download-upload speed in kilobytes per second. Lower values correspond to darker blue areas, together with the location of the antennas. We're going to start from this data, which is synthetic data that I have generated for this use case, and enrich it with some location data, some from open source data, others from proprietary data from the Carto platform, and then use Carto to create our analysis. So let's start by taking a look at the different data sources that we can use for this analysis. In order to simplify the analysis for this webinar, I've already gathered all the different data sources on a common grid. As you can imagine, when you look for different data sources to use in a use case such as this one, they all come in different shapes and formats and different spatial supports. So one type of spatial support that can be used in this is the spatial support that we are using here. It's called quad bin or quad bin grid. And quad bins are a type of spatial index. For those of you who don't know what spatial indexes are multi-resolution hierarchical indexes that can be used to split the geographical space into regular grids, where each grid point is uniquely defined by a string of digits. So they are very useful when it comes to combining large data sets, because you just need a simple join and you don't need complex spatial operations like intersections. And this is very handy when it comes to telco data and telco use cases, because usually you need a lot of data. So in terms of the data sources that we're going to use, we're going to start with an open source data about buildings height from USGS, as you can see here in this map. This is important because we know that higher buildings can impede the network transmission. We're going to also use some Carto proprietary data taken from Carto spatial features, including the level of urbanity. We can imagine that areas, more urban areas, might be associated with a higher network transmission speed. The working population, identified as the population over 15 years old. The senior population, which is our target. The number of points of interest from different categories: healthcare, retail, transportations, and so on. And finally, the elevation. Sorry. Apart from this data, we're going to also include some human mobility data taken from our provider Unacast. Specifically the number of visitors identified as workers, and the number of visitors that were identified as neither workers nor residents. So all these data, as you can see, have been gathered on a common spatial support using quad bins, and the resolution I've used is quad bin 15, which is about 1 kilometer at the equator. Right. Once we've gathered all the data, we can then start our analysis. This use case is organized in 3 different parts. And each part correspond to a workflow. So if you've never used Carto workflows, this is what you're prompt to when you open new workflows. Carto workflows are a low-code approach to spatial analysis where you can combine data sources and spatial components that perform a particular task or analysis together to create complex analysis like this one, for example. So in the first part of this analysis, we're going to use this workflow that basically what it does, it creates an eligibility model. So taking all the data sources that I've just mentioned and the transmission speed data, we're going to generate a regression model that estimates the network speed everywhere in the US, not just where we have currently our clients. And this is useful because then we're going to use these estimates to create our priority score. And for that, we need estimates everywhere in the US. When you create a workflow, you can select the input data by looking at the sources tab and the different components, looking at the components tab, as you can see here. So the input data, which you can see by clicking here and going to the data tab, as you can see, is the quad bin grid with all the different variables that we have just mentioned. So I'm going to start by doing some pre-processing. So first, I'm going to select only some of the variables that are part of the input data, and then we're going to filter the rows where we have data about the network speed. So in this case, the network speed is defined as the average kilobyte per second of each grid cell. So this data is then passed to this component called create regression model and predict, which basically under the hood, what it does is that it call BigQuery ML library to create a regression model, and then use this model to predict. So of course we need to identify the dependent variable, in this case the network speed, but then also we need to say all the different model options, for example the model type, how we want to split the data, all the different options that basically are available as part of BigQuery ML library. So in this case, for example, we're using a boosted regression tree, and as you can see here, we are saying that we want to split the data randomly in order to tune the hyperparameters, the number of search in the hyperparameter space that we want to make, and so on. So once we do this, we can join the estimates from the model to the input data and save the results to a table here, which we can then use to create a map like this one here. So here what you see is the estimated network speed in millibytes per second for rural areas on the left and for urban areas on the right. As you can see from the widgets that I've added on the right, as expected, we have a much higher network transmission speed in urban areas than in rural areas, but also within rural and urban areas, you can see some differences. So if we go to the second part of the analysis, then we can see we have another workflow, and in this case, the workflow is about creating the priority score. So again, the input data is the same data as before, plus a new column, which is the estimated network speed. What we're gonna do here is call this component called create spatial composite with weights, which basically create the priority score. So if you've never used composite scores, basically this is just an umbrella term to describe ways to summarize multidimensional data. The simplest way is probably to scale the variables in order so that they are comparable, and then aggregate them, for example, linearly or geometrically, and assigning different weights to the variables in order to weight differently the contribution from different variables. So this is the method that we're using here. And to do this, we're gonna select three different variables: the proportion of senior citizens in each grid cell, the estimated network transmission speed, and the level of urbanity. So we want to create a score that indicates higher priority when there are more senior citizens, when the proportion is higher, when the network speed is lower, and when the urbanity level is also higher. So in order to do this, we have to go through a pre-processing step where we create a new variable, which is the network speed with a reverse sign. So basically, I've multiplied the network speed by -1. And I'm doing this and using this variable instead of the original network speed in the creation of the composite score, because in this way we have variables that are all compatible within each other. So the final score is more interpretable. In fact, if we would use the original variables, we would have had that higher values of the proportion of senior citizens, which in terms of priority should be beneficial, would correspond to a higher value of the network transmission speed, which instead should be more beneficial to the score with lower values. So if we do this, then we can call this component. And you can see here we need to specify the different input parameters. So for example, which scaling function, how do we want to scale the data? In this case, we're saying that we are transforming each variable to its percentage rank, because we have a variable that it's an ordinal variable, the urbanity level. Then we have to say how we want to aggregate the variables. We're saying here that we're doing this linearly, and which variables are we're gonna include. So the reverse of the network speed, the urbanity, and the proportion of senior citizens, and also the associated weights. And finally, we're saying that we want to bin the final results into 5 different priority levels. And finally, again, we are saving the results to a table that we can use then to create a map like this one here. So here, what you see is the priority score that we have just derived. So a higher value indicates areas where we should focus our efforts in improving the accessibility to senior citizens. And this is because there is a larger proportion of senior citizens, the areas are more urban, and we have a lower current network speed. Right, so let's go to the last part of this webinar, where we're gonna use the AI through large language models to create automatically some labels for these priority scores that we have just generated, in order to be able to better interpret the results and share these results also with non-technical people like stakeholders. So the input data is the same data as before, plus a new column, which is the score in categories from 1 to 5 that we have just generated. We also have a second input data in this case, which is a table containing the variable, all the variables in the first table, plus a description of each of the variables that we can use to then create the prompt that is passed then to the LLM model. In the second part of the workflow, here is where we are calling the LLM model. In this case, we're using Google Palm 2 model. And we are calling this through this component that we've created. It is called Describe Groups with AI, which basically what it does is create a label through the LLM model for each priority group. So the idea behind this component is that first it generates a prompt by summarizing the data, the input data through some statistics, for example, the mean of the variables or the sum or the mode, depending on the variable type. And it does this by priority group and also for the whole population. And then using the description containing in the dictionary, it generates the prompt associated with these variables. This, together with a task that we input as part of the parameters, can be used to then finally generate the prompt that is passed to the LLM. So in this case, the task, you can see it here. Let me zoom in. So I'm basically saying that what I'm passing is a priority level, that it was created by taking into account 3 different variables: the network speed, the proportion of senior citizens, and the urbanity level, and that I want the AI to generate labels for each of them in a human readable format to help stakeholders take decisions based on this score. So the other parameters that you can specify here about the how you need to connect to the LLM model, so the connection name in BigQuery and the table name of the model where you store the model, are some parameters which can be used to tweak the LLM. For example, the temperature, which controls the degree of randomness of the LLM, and then some parameters, the top K, top P, which defines the way the tokens are selected by the LLM. So if we run this and then join the results with the input data, and again save the data, the results in a table, we can then add to our map a description of this of each group as generated by the AI. So, for example, for this group, the AI says this group is characterized by a high network accessibility priority score, a low average kilobits per second, and a high total population of people older than 65. This suggests that this group is in need of improved network connectivity and services to better meet the needs of the senior population. So this is just an example of what you can get, and of course, including more variables will make the description more interesting. But I think it shows how powerful this tool can be to broaden the result of the analysis, not just to technical people that know how this score has been created, but also to stakeholders that by just looking at this dashboard can derive some useful insights. So that's all for today. So thank you for joining, and see you at the next Spatial Spotlight.